Yeah, good stuff.
All right, welcome to the November 11th, 2024 AnonCreds work group meeting. A holiday in Canada, but let's get a meeting or two out of the way. Topics, summary of it's actually, I meant to change that, not a revocation scheme design proposal. Status about the Revocation Manager project that Victor's working on. We can talk a bit about the ZK circuits-based approach that was proposed by Google at IIW. Reminder, we're recording this call, and the Linux Foundation antitrust policy and the Linux Foundation decentralized trust code of conduct are in effect for this meeting. So for this scheme, you guys have seen this. Mike, you've seen this. The biggest question I've got on this is how many operations per second can a witness server operate? That really would dictate the scale. If a witness server serves many holders and many holders have many revocation revocation registries, revocation elements. And a witness server spends its time simply updating holder witnesses. How fast would those operate? So therefore, how many holders could it? I'd love to be able to sort of put some numbers behind that.
Okay, so I think there's two types of updates, right? One where they were just given the witness directly, and the other
Yeah,
they're trying to be anonymous,
let's
right?
let's start with just giving the witness.
Well, that's just really copy and paste, right? I just I verify you somehow through authentication, and then I just return a value, and that's
No, no,
it.
no, but the witness server has got every once in a while it realizes, oh, there's new revocations on a registry and some of my holders have that registry. So I go grab that update and then I update all of my holders that are using that revocation registry. How long does it take to update a witness, you know, given a single revocation and a single witness, how long does that operation take? And therefore, can we scale that out to figure out?
Uh, okay, so let me maybe walk through the flow a little bit. So
Okay.
the revocation manager says, all right, I'm going to publish an update where I've removed values and the accumulators changed, correct?
Hold on, removed values. I
Well,
thought
that's
you
the only time
added
you have
values.
to update the accumulator is when you remove, right? Or delete.
Yes. Okay.
Yeah.
Yes. But
So I'm just going to say remove.
no, let me just clarify that again. I always want to make. I thought that the issuer adds new ones. Oh, and then they get removed. So the issuer tells the revocation manager what all the elements are.
So here's the cool thing. Um, so the revocation manager is just the key manager, right?
Yes. Yes.
Okay. So the issuer just says, when I issue a new credential, I need you to create a witness for me for this credential, right?
Okay.
Then the issuer can take that witness, they're going to give it to the holder, and they're going to publish it to the witness server, right?
Okay.
So can you scroll down a little bit? I'm trying to see where the witness server is getting the data. Okay.
So the idea of this data structure is it's a timestamp and a list of GUIDs that have been revoked.
Okay. Yeah. So, all right. So
And
the
then the other
issuer
one,
is going to
and then
hand
just to
out.
and just to wrap this up, this one over here, the accumulators is just a timestamp and the accumulator. And
Yep.
the timestamp is obviously common between these two.
Yeah.
Yeah,
Okay.
okay.
Yeah. So the issuer basically is going to indicate, hey, I've issued some new credentials, right?
And they're going to
Or
tell the revocation manager that.
He's going to tell the revocation manager that the revocation manager is just going to return the witnesses. Whenever things are added, that's all he does.
Yeah.
Just, all right, here's the witness for that value that you add or values that you added.
Yeah.
Okay. The issuer publishes those, and then the witness server just fetches those, right? At this point, the holder just got it. He doesn't
Whoa,
need to
whoa,
update
whoa, whoa,
anything.
whoa, whoa, whoa. Well, the issuer only publishes things when things are revoked, not when they're issued.
Um, well, so then how does the witness server know to update something?
Okay, I thought the way it worked, sorry if I'm got this wrong. So I thought during issuing the revocation manager, well, I didn't think during issuing anything happened. I thought during issuing the issuer just tells the holder, here's your element. But you're saying,
Well, okay, so he tells him, here's your element and here's your witness, right?
here's your witness. So they tell them both, and the revocation manager is involved in issuing them.
The only thing the revocation manager does is he just creates the witness, right?
Okay.
Because he's got the keys.
Yeah.
You can only create a witness if you've got the keys.
Okay.
Okay. So
Got
then
it.
let's just say the revocation manager or the issuer hasn't revoked anything, and then the next day the holder goes, "Hey, I want to check for updates." And even though nothing's been revoked, he's
Right.
going to check the witness server, and the witness server is going to go, "Well, okay, I don't see anything revoked, so I guess your witness hasn't changed, right?"
Correct.
This is just the easy path
Yeah.
where nothing's happened.
Yeah.
So how does the witness server know nothing's been revoked? Because there's no new revocation managers or revocation value and timestamp have been published, correct?
Exactly. So actually, what the holder gets is a timestamp
And the revocation value,
and
or
the revocation value
accumulator
and
value.
the witness.
Yeah, they need the witness, the accumulator, the timestamp, their value in it, and anything else associated, right?
And this guy then says, here's the current witness and here's the timestamp for it. The witness server goes and looks, oh, there's nothing after that timestamp, therefore nothing's changed. And so your witness is still good.
Yep.
Yeah.
Okay.
Okay.
Okay, that's great. So that flow we understand, right?
Yeah.
Okay. Now, sometime later at time T, issuer goes, all right, I need to revoke like 600 credentials.
Exactly.
So then he says, revocation manager, revoke these. The
Yeah.
revocation manager, the only thing he does is returns the new um, accumulator value,
And the
right?
timestamp.
And the
Let's
timestamp. Now, here's where it's a little vague for me. Does the issuer have them recreate every witness for every issued credential at this point?
the issuer simply publishes the timestamp and all the GUIDs of the elements, just the elements, I'm calling them GUIDs just
Oh, okay.
and
And
then also publishes the timestamp in the accumulator in this file. So one file gets the list and the revocations, the other file gets the list or the timestamp and the accumulator.
okay, so the revocation manager will also need to return the deltas too, right? So those that want to update anonymously can or no?
No,
Okay. All right. Well, let
not
me
that I know of. What does that mean? Sorry.
well, so the deltas are like if you want to offload the computation for updating your witness to the witness server.
Yeah, I mean, that's what's the deltas are what gets published here. Each batch is a
Yes.
timestamp
Yeah.
plus a list of the things that got revoked. The
So yeah, the
600.
deltas, the revoked elements,
Yeah,
and
that's,
the timestamp and new accumulator. Okay.
yeah.
All
So
right.
the issuer's done that. Now the witness server detects that there's a new value, there's a new record here.
Uh-huh.
So it retrieves those 600 updates and because it already holds a bunch of holder witnesses, it updates them
How did
all.
it get the holder witnesses? That's the
The
part.
holder
Yeah.
said, hey, I want you to be my witness server. And so it passed in, here's my timestamp and here's my witness.
Okay.
And then the witness server continuously updates that service, whether the holders ask for it or not. Whenever it sees that there's a new record in the registry, it goes and grabs it and then updates all the witnesses for all the holders that it has.
Okay.
And then periodically, a holder would call in and say, "Hey, give me my latest updates," and the witness server would say, "Here's your new witness and the new timestamp for it," and pass that to the holder. So it
Okay.
doesn't do it. So the witness server doesn't do it based on when the holder asks. The holder asks up front, "Here's my witness, and here's the revocation registry and the timestamp." And the witness server then continuously keeps it up to date. And then whenever the holder wants it, it asks for it.
Okay. Okay. That works. All
Okay.
right. That's the part I was missing was how does the witness server get the witnesses?
Yeah. So the whole idea is the holder, and essentially the way I envision it is the holder might have 10 different revocation registry. It gives all 10 of them to the witness holder, says update all of these, and the witness server is, as I say, continuously monitoring all 10 revocation registries and updating the witness for all the holders that use each of those revocation registries, and
Okay.
scale up from there.
All right. So the holder has some way of enrolling and saying, watch this for me.
Exactly. Yes,
Okay. All right. And even if it's breached, the only thing the bad guy gets is the witness. He can't do anything else. So,
exactly. Yep,
because everything but the witness is public anyway. So, but the witness by itself is useless.
exactly.
So,
That's what I'm hoping.
well, it is because you have to know the actual element in the registry, which is never
Exactly.
published except by
And never given to the witness server. Okay, good. Yeah,
yeah,
that's what I'm
that's
saying.
only the issuer knows those values
Yeah,
and the holder only knows his own,
yeah,
right? And two, it has to be paired with a signature proof anyway. So they have to have the credential also in order to make this work,
yeah.
right? In my mind, you should never accept a revocation proof without a corresponding credential proof.
Right. Yes.
Yeah. Okay. So really the only way this gets broken is if the holder's stuff gets compromised anyway.
Yeah.
Oh. All right.
And then the idea I've got as well is this is likely run by the company, if you will, or whatever, the organization that gave the holder their wallet. And that organization already knows everything in the holder's wallet.
Okay.
So that way you have fewer, you know, parties involved. So for the BC wallet, there's the BC wallet, and then the BC wallet would publish the witness server for that.
Okay.
Anyway, so the question now becomes, so now we see how it works. Every time the VC, so issuer does need to contact the revocation manager during issuance.
Correct. And
Okay.
revocation.
And during revocation. See, I've only got the one here. Okay. And then
The
and
nice thing
this and
is the nice thing is the accumulator itself doesn't change, right?
right.
So
Yes.
during issuance, the issuer doesn't have to publish anything.
Right. And those can be done by batch. It just says here's 100, or
Yep.
here's I need another 1,000, and so generate a bunch of witnesses for me. I get the elements and the witnesses back, and then I start
Yep.
issuing them. Um, okay, and then when I when the issuer revokes, it sends a batch of revoked credentials. It gets an updated accumulator and timestamp, and then it publishes those out to these things. The witness server then detects and updates the witnesses it has, and then periodically the holder says, "Hey, give me my witnesses," and the
Yeah.
witness server gives them to them. And then, as I say, ideally independent of when it actually contacts the witness server, it does a verification based on the latest witness it has, assuming it is fresh enough for the verifier.
Yeah. So
Okay,
now we can answer the question, how fast can it go? Well, if it's already
exactly. So,
updated the witness, then it just hands it over and you're done.
no, the holder. But how fast can the witness server update the witnesses?
So it's actually pretty quick. So there's ways where we can do like, if it's updating them every day, it
Yeah.
can, depending on how many revocations happened,
Yeah.
let's say it's 600, so something large, or even 1,000, okay, or
Okay.
10,000, right?
Yeah.
So an individual witness will take about, I don't know, half a second. So it's not very long.
Okay.
And then they can all be parallelized, right? Because each one's independent of each other. So you just run a job that says update all of these in parallel and then save the new values, right?
Now, when you say parallel, um, can that is that meaning that you can have multiple instances of the witness server, or can it actually parallelize math operations on a single
Yes.
server?
Yes, you compare. So, like, for example, I have witness A, witness B, witness C
Yeah.
that all pertain to the same accumulator, and they're
Yeah.
all going to be having applied the same update
Yeah.
mathematically to all
Hmm.
three of them. You can run all three of them in parallel, code wise, on the
On a
same
single on a
on a
single
single
server. So
server.
Rust would have capabilities to do something like that.
Oh yeah, yeah. You just say parallel iteration, and then bam, bam, bam. It'll do what however many cores you have on the CPU at that, on the
Okay.
server at that point.
Okay.
So it's actually a pretty light operation to do it, and they can
Okay.
run in parallel. So
Okay.
worst case where you have thousands of them, I'm not saying hundreds of thousands, but let's say like tens of thousands,
Hmm.
less than 50,000, you're looking at about half a second. Once you go above about 50 to 100,000, it's about a second. Any higher than that, and it gets to be a little, unwieldy. But it's
So
it's
what
only
number should
a
I
second.
use? Did you say 10,000 to be a half second?
Yeah,
That's a good one to use. That's
yeah,
a good
about
metric.
yeah. So if we say a half a second for every 10,000 revoked changes,
Okay.
revoked
And
deltas. Okay.
that can be parallelized up to the number of cores.
Yep.
And
Yeah.
then okay.
So let's say you have 8 cores, and with threads, you're up to 16, right? And let's say you have 128, because I'm doing powers of two right now. I
Okay.
have 128 witnesses I need to update. So, I mean, that's going to take you 2 seconds to update all of them. Not bad, right? It's half a second for every 16 you have, and 128 divided by 16 is 4 or 8. Yeah. Oh, so wait, it'd be 4 seconds. Yeah. Because half a second times 8 is 4 seconds. So not bad.
Okay.
That's for a large batch. If you go like say 600, you're even faster than that.
Yeah. So if you're saying and just it's the number of threads, not the number of cores.
Right. Well, because
Okay.
most CPUs these days are hyper threaded, right? Which gives you
Yeah.
two
Okay.
threads per core. So,
Okay.
but I mean, if you had a
Okay.
really beefy server, I'm not talking. I mean, extreme case, you're paying a 500,000 a month for one of those extreme cloud servers, right?
Yeah.
That's like 64 cores, 128 threads. I mean, you're talking just really fast update thousands of these things with large batches. But if you're only updating or revoking a few every day, and like I said, what you may want to do is kind of cover traffic, is just so nobody, it makes it harder to be correlatable since the revoked elements will be published.
Yeah.
Say, well, we're always going to revoke 1,000, even though only like say 40 got actually revoked. The other 960 are just kind of cover elements.
Oh, interesting.
Well, it's just a way so a verifier make it's harder to correlate, right?
Yeah.
Oh, you were one of the revoked ones. Well, I don't know which one. It was one in 1,000, right?
Okay.
I could
Now,
try all of them, but I don't know. But here's the thing. Even with the zero knowledge proof I've been given, I can't test it because it
yeah.
was it was hidden by a bunch of other stuff too, which I
Yeah.
don't have. So it doesn't really help. The only thing
Yeah.
they know is that okay, someone tried to present to me, they were revoked. It could have been one of these 1,000.
Yeah. So just managing the data is going to take as much
That's the bigger lift, actually, is just
Yeah,
data management.
data management. Yeah,
And it's all on the issuer, which is kind of nice.
yeah.
And we have
Okay.
databases for this sort of thing. So let's say you want 1 million, you want to be able to issue 1 million credentials. See, here's the cool thing. No one on the outside except the issuer knows how many elements are actually in the accumulator, right? They
Yeah,
just see the accumulator, and until you actually revoke something, well, even after you revoke, you still don't know how many are in there.
yeah. Okay.
And if the
Let me
issuer is
ask.
breached, it still doesn't help them know, okay, they go, all right, now I've got the elements, and then if I breach the witness server, I've got the witnesses. I can,
You
um,
still don't know anything because the presentation doesn't share either of those.
right. The presentation doesn't share. The only thing they could do is forge a single revocation proof. They couldn't forge the credential. They couldn't forge anything because the keys are at the revocation manager.
Yeah, wild. Okay, so now let me ask one more thing.
Hmm.
Suppose we decide to shard this plan. Suppose we have three witness servers and the holder shards its witness between the three servers. Could the could everything operate the same except the holder asks two out of the three when it gets an update, when it says, "Hey, I want to update my witnesses. Give me, give me my updates." The witness servers could this plan still work the same with sharded witnesses versus a full
Yes.
witness? Yeah, that's what
Yeah,
I
it
thought.
just might. Yeah. So the difference is the holder. Well, so the difference is the witness server is going to do the computation on the fly because they don't know which witness they're updating, right? So they haven't pre-computed anything. So all they can say is, all right, you're going from accumulator A to accumulator B. Here's all the deltas. You gave me your shards. I'll just do that half a second, like I said.
Whoa, whoa,
I'll do that
whoa.
on the fly
Why does it have to do it on the fly?
because it doesn't know which one they're updating.
No, no, no. I'm saying it the holder registers a shard. Can it not it can so the witness
No,
can
you don't want to
continue.
store the shards.
Oh, you don't want to store the shards. You can't
No,
update the shards continuously.
no,
Okay, that's what I was wondering. So you
no, you don't
can't
do that.
update
That
them.
would be dangerous.
And why would that be dangerous?
Because it's not the shard of the witness, it's the shard of the value in the accumulator. So let's say
Oh,
I gave you one shard on one server, I gave you another shard on another shard on another, and let's say it was 3 out of 5, right?
yeah,
So
yeah.
if I break those three witness servers, now I've got your value also with your witness.
Oh, so you have to give both the element and the witness shard.
Well, the witness is not sharded, just the
Oh,
your value that's in the accumulator is what is sharded.
oh, okay. That wouldn't be so good. Okay, I thought it was just the witness that got. See, I've got current witness shards here. That's wrong.
Yeah, it's not witness shards, it's element shards.
Oh, but hold on. Does the holder have to give the element to the witness server
No,
if there's a
no, not
single
for the
witness?
not for the first approach.
Oh, that's huge then. Okay. Okay.
No, for the
Got
first approach, all the first approach just says take the deltas and the witness and apply the updates. That's it.
I get it. Okay.
Whereas the shards, it's like I don't know which witness I'm updating. All I have is the deltas and shares of your
Element.
element. Now do that, and that's the unique thing. One of the unique things we added with the ALLOSAUR paper. So
Okay. Okay.
was all right. Now update me anonymously, and then when I get back is a value that the holder once they get all their computations back from the witness servers. So they
Mhm.
send in an element shard and they get back a witness shard is actually what they get back.
Yeah.
And then they combine the witness shards to get a witness update, and then they apply their witness update to their local witness, which is a very fast computation.
Got it.
Then they're
Okay.
then they're current.
Okay.
So it's a witness update shard. So they send in
So
an element shard, they get back a witness update shard.
yeah,
Luckily, the witness servers don't have to talk to each other to do this.
yes, yeah.
There's no
Okay.
empathy.
So the changes here is issue. I've got to add another link here to issue,
You could
and
just
then
say issue
I got to
credential and
return
revoke
shard.
credentials, right? It's the same thing.
That's true. I could just say that. Yeah.
Returns accumulator, timestamp, and then on revoke, it'll also return the deltas. But otherwise, your flow
Hold
chart
on.
doesn't change.
Hold on. Doesn't it hand in the deltas? Basically, the list
No,
of what is the
no.
delta?
It only hands in the revoked credentials like you have there.
What is the delta then?
The deltas are a way to update witnesses without the private key. Think of it as like pre-computation with the private key. Without the deltas, you would have to have the private key to do the update. We don't.
Okay. So and what are the deltas? Just a number for every accumulated.
Not
What is
not exactly. It's like a log n value of, so if you, let's say you had 128 values revoked,
yeah.
right? That gives you like 5 deltas, for example.
Sorry. And but what is a delta? Is a delta a number?
Yeah,
Is it
it's
128 numbers? So if I revoke 128 credentials, so the BC issuer passes in 128 numbers, what amounts to numbers, what does the revocation manager return back to the issuer
they return, so the revocation manager returns back to the issuer. You're talking about on revoke, right?
on revoke?
On
And we're
revoke,
talking,
they return the new accumulator,
okay,
timestamp,
yeah,
and what they call the I call them witness updates, or deltas is the same thing. That's what they are. Is their
okay,
deltas. Think of them as like they're computations that if you have the private key, you can create these. Without it, you can't. Um, but they basically give you like, it's like a polynomial that says when you evaluate this polynomial, this hidden polynomial, think of it as like I'm encrypting a polynomial to the private key. And once I've done that, then when you give me so let's say the holder got these deltas, they could apply the
yeah,
updates themselves, right? It just
yeah.
says evaluate this encrypted polynomial to my element, and that gives me the delta that once I add it to my witness, I'm current.
Okay,
That's
so that's
the
not what
delta.
I'm asking. What I'm asking is it what is the data type of an element and how many are there? Is it a number? Is it a number plus the element?
So the elements can be whatever you want, Stephen. So this is
Yeah,
where
no,
I've
no,
said
no, I know that, but I
it
mean,
can be
is there
GUIDs.
one delta per element?
No, no. Like I said, it's like a polynomial like thing.
Okay,
So it'll vary in length depending on how many credentials you revoked.
okay,
It's a good guess is roughly like log n. So if you revoke 128, you'll get roughly 5 to 6 back.
and
They're not very big. They're just a point. So on the BLS 12301 curve, that's 48 bytes per delta you get back.
okay. So let me walk through this. So if I, as an issuer, I put in GUIDs here of, so I'm using GUIDs as the
Uh-huh.
element.
Yep.
So I pass in, I revoke 600 of these things. You're saying I only get log 600 of those back. And
Roughly.
that's what I publish down here.
Yeah. So you get back about, I don't know, somewhere between 8 to 10 deltas along with the accumulator. Yeah.
Oh, I thought the length of the record here for each batch would be based on the number of revocations, but you're saying it's log of the number of revocations, so way
Well,
shorter.
well, so you're also publishing the revoked elements, right? Which you
I
actually
don't.
don't need to.
I yeah. I wouldn't if I don't need to. I
Nope,
don't
you
need
don't
to, I
need
don't.
to. Nope,
Okay.
just publish the accumulator, the timestamp, and the deltas. That's
Okay. So, so that, and to be practical, that would be a base 64,
I mean,
base
you can do
64 of a
encoding
number.
is we're just getting into semantics, right? Like
Yeah.
encoding is whatever you want, but
Yeah, I know.
a byte
Right.
form, each delta is 48 bytes.
48 bytes.
And that might be wrong with the number of deltas. I mean, I could try running a test on it right now.
Okay,
Um,
so
that
40,
actually
so
might
it
be
is
good. Let me
fairly
do that.
long. So each delta is fairly long.
Um,
Relative, like it's much longer than a GUID, right? How long is a GUID?
yeah, 48 bytes is definitely longer than the GUID, right? GUIDs are only
Yeah,
16 bytes.
yeah, that's what I thought. So
Uh,
I'm getting a benefit of log n, but I'm doing
bigger data.
3x, 3x the size.
Yep.
Yeah, so I'm getting 3 log n
All right. Let me
of the
see.
number of revocations is the length of it. Okay, that's interesting. Okay.
I'm going to do a test right now. So give me a second to give you actual better numbers. And maybe I'm being too conservative. I hope I'm not, but maybe I am. Wait, open.
Oh, that's interesting.
So we'll see. Yeah,
The
you don't actually have to
revocation.
publish the values that were revoked, just the updates or
Yeah.
yeah, just the deltas. All right, let's see here. All right, so let's see here. Where's my tests? No, I don't need that. Um, don't need that, don't need that. Where are my tests? Am I in the right file? Oh yeah, here it is. Okay. No, I'm not gonna do the 1 year. That would take a while. All right. How many? Okay, let me do a test here. How many do you want to revoke so we can just see?
Um, what's my range? 500? Can we do that many or?
All right, I can start with 500. That's fine. All right, I'm just writing it real quick. Oh gosh, come on. All right. Oh, now I got to do 500 random values, right?
Yeah. Sorry. Make it, shorter if you want.
It's fine. I'll just figure it out here. All right, I'm going to go to a different place here.
And then the calculations the witness server has to do is when we talked about the 10,000, that's with deltas. So it would
Right.
actually be far fewer deltas because that would be if it was 10,000 deltas, that would be way more revocations.
Oh yeah, it would represent way more for sure.
Yeah. Okay. And there's never going to be that many revocations in a day.
I mean, at that point, you might as well just start a new one, right?
Yeah. Okay.
See, it's a Hyperledger. Is it Hyperledger Labs? Is that where it was? Agora,
Yeah.
Allosaurus, Rust. Oh, why is it not showing up? Because I wanted to commit it in case we wanted to.
No.
I don't know why it's not showing up. Oh, there it is. Oh, it's RS. Duh. That would help if I spelled it right. All right. Open. Yeah, I think this will be helpful to know. That's why I'm just going to do it right now rather than try to guess. And then you go, Mike, you're way off. Samsonite. Where's the tests? In here? Okay, here we go. All right, so you want me to put in 10,000. I'm just, well, yeah, let me do this. Okay. What? Do I not have any? Oh, darn. All right, hang on. Okay. Yeah, so if you just publish the deltas, we should be good.
And it's log n. So
Hopefully, I believe so, but I want to double check that.
okay. Oh, and that's what you're double checking now. You're still working through it.
Yeah, I'm just double checking. Okay, so now, let's see. I'm going to remove create 500 elements and then remove them. Remove. Where's my deltas? Where are they? Uh-oh, am I not returning it? I thought I had that somewhere. Where is it? Why is it not returning my deltas? Uh-oh. I wonder if I accidentally deleted that part. No, I can't have deleted that. It's got to be there. Oh, here it is. Okay. All right, so if I'm removing 500, let's see how many it creates. Okay, deltas dot length. There we go. Assuming that this is correct, should be. Oh, it's got to compile. Give it a second. Let's see. How many did it give me? What? Ugh,
How many?
way more than I thought it would. Why was I thinking log n? Oh,
How
that's the
many?
number of operations. Okay. Now I remember this. Okay. I was mixing it with something else. So the number of coefficients or the number of deltas that comes back is equal to the revoked elements.
Okay.
Let's see. So like if I added 500 and removed 600, I would only get 600 back. But if I added 1,000 and removed 600, I would get 1,000 back because it's whatever is greater. So yeah, it is the same size as the
Same
revoked
number is
element.
okay. Well, that's unfortunate, but oh well.
It is.
Okay.
It
And
is, but
it's
you're not actually returning the elements themselves, just the deltas.
but
So
that means that the data size is 4 times larger than what we thought.
yeah. So instead of 16
Instead of
bytes of
16
revoked
byte
elements,
GUID,
it's
we're
gonna
getting
be
a 64 byte
No, 48
Base
byte.
64. Yeah, but
48
it's
byte. Oh,
yeah,
but you're
base
base
64.
64.
Base 64 is going to be 64. Okay. And um and then the number of operations is the same as the
Yeah.
number of revocations. Okay.
Yeah.
I mean, the log n would be ridiculously
That would
that
be
would be
nice.
simple, but okay. So we're much higher data than I talked about. Other than that, we're the same. Okay.
Yep.
I just have to refine things. So the size of the data is going to be much larger, four times larger. Okay.
Let's see. Data encoding. Yeah, you want base 64 URL encoded, right?
Yeah, I did the math on that one already. I'm pretty
Let's
sure anyway.
don't spoil my thunder.
Okay.
Oh, wait, what? Rate coefficients. Am I looking at the right thing? Yeah, okay. That's what I thought.
And if you only issue credentials, you don't change the accumulator.
Yeah,
So
that's
you
right.
wouldn't want to do them at the same time.
Yeah, I mean issuing does nothing, right?
Right. That's what I thought. But you talked about if you issued 600 and revoked 1,000 or whatever, you wouldn't want to do those at the same time, would you? Or would it matter?
Oh,
You
it
still get
doesn't
the
matter.
deltas back that have to get published, right? And those are the same no matter what.
Correct. Yeah.
Yeah, okay.
The deltas, you don't need any for adding, just removing,
Yeah,
right?
exactly. Okay. All right, we ate a lot of time up. Victor, do you have any update? I'm going to update this paper and get it right. Um,
Yeah, no. I updated the to-do list and as well as the markdown
okay,
in, in my project, and I also included the Docker files and all the
excellent.
Docker requirement like TXTs for to set up the Docker file,
Okay,
and I think it's running. I'm able to run it on my Docker container.
excellent. Okay.
And
Can you
yes,
share in the link, remind me the link to the markdown? You could just share that.
it's right here. You can find the to-do list and the markdown in like right in this main image.
Oh, okay, got it. Okay. I was thinking you meant the wiki page. Got it. Okay.
Oh no. Uh, yep, and then I'm going to separate the witness server as you guys told me.
Okay.
Yep.
Excellent.
Yeah, that's
All
pretty.
right.
Steven, you're correct. It is 64 characters and by 64 encoded.
Okay.
All right, let's go Z80. Come on. Let's make it even smaller.
Well, I mean, they're going to go across. So the other things you can do, I think, is, assuming the witness server supports it, is it can send to the witness server can say, give me the latest updates from this point in the file onward. So if you make the file continuously growing, you can have the offset. So all you get, instead of getting the full file every time, you only get the changes that witness server wants. Um, if the holder knows that value, the holder could even request an update independent of the witness server just for a temporary use, and only get the updated one since the last. So there's a bunch of things that can be done anyway. If at the HTTP level that makes this improves the performance.
Yeah.
All right, I have got another meeting coming up, so If it's okay, we'll call it.
Sounds good.
All right. Much appreciated. Get better, Mike. Take care of that Achilles.
I will.
All right. Take care, all. See
See
you,
ya.
Victor.
Bye bye.
Bye.